to your second class on applied maths. So we're in the middle of lesson 1. So today, if you look at your notes, which you've downloaded, you will see that we're in uniform acceleration motion, or what I call UAM for short. And in lesson number 1, we were looking at horizontal UAM. That's going along the ground, cars, trains. And later today, I hope to finish lesson 2, which is vertical UAM, and that's going up and down. That will involve falling objects. So let's get to it. So what did we do last day? Well, last day we had our equations. Look at our 5 equations. We actually derived those equations. P is equal to U plus AT is number 1, all the way down to number 5. Now I said to you the first 4 are actually in your table book. That 5th one is not in your table book, but I find it very useful. It gives me a complete set of equations. It means that in most problems I just have to go to one equation to get my answer. Now you're dealing with 5 letters all the time. You're dealing with S. That stands for displacement. Now displacement, we need to be careful of today. Displacement and distance are 2 different concepts. I'll go over that again when I do one of my examples later on. Displacement is measured in meters, time t in seconds. We're going to have 2 velocities. We're going to have the initial or starting velocity, and that's measured in meters per second. And the final velocity, also meters per second, of course. And then, to go from one velocity to another, you're going to accelerate. Acceleration is that change in velocity. So the acceleration is measured in meters per second squared. So we went through all of that. How do we use our equations? Well, I have this nice little technique. You've got 5 letters in total. Each of these equations has 4 letters. There's 1 letter missing. For example, in the first one, there's no S. And that's the key to knowing which formula I'm going to use. The second equation has no A. The third equation has no V. The fourth equation has no T. And the last equation has no U. So that will be my key. Basically, to do all of UAM, that's all I need. Those equations, as I said, are in your table book, but look, every proper applied maths student will know them off by heart. They're going to be used in practically every section that you do in applied maths. So you really don't have to be looking up your table book for these. You should know them automatically. We have something called the 3-letter rule that we talked about. Once you have 3 letters, that's great. That's what I call breakthrough. Once in any part of a problem I say I've got 3 letters, I say great, now I can solve the other 2. So once you have 3, you can go to 5. So that's my technique. So let's go and do our examples. So let's go back to my notes. So where were we? We did example 1 and 2 already in class number 1. You had some exercises to do as well, where you practice using the formulae, so you should now be very, very expert at using them. Now I'm on to example number 3. So body travels 238 meters in 14 seconds with an acceleration of 2 meters per second squared. It appears I have 3 bits of information, and that's good. That means I can find the other 2. We want to find the final velocity, that's V, and the initial velocity U. Okay, so let's look at that question in detail. Now here's my question. I always start by drawing a very simple diagram. We're talking about drawing a line, a horizontal line. So there's my horizontal line. What am I told? There's my starting position. There's my finishing position. I'm told it travels a distance of 238 meters. So that distance from start to finish, that there represents 238 meters. S is 238 meters. The time it takes to travel that distance, that's 14 seconds. T is 14 seconds. Do I have any other information? Yeah, I'm told it's got an acceleration of 2 meters per second squared. I always put the acceleration off the diagram like this as an arrow, and I write down that A is equal to 2 meters per second squared. Look, the great thing here is I've got 3 bits of information, so I can work out the other 2. What are they asking me to work out first of all? They're asking me to work out the final velocity, v, first of all. So you see those 4 letters there? What letter are you missing? The letter you're missing is no U. So if you go back to all my equations here, where's my equation with no U in it? It's equation number 5, isn't it? It's the one that's not in the table, look. So this is handy. Otherwise, what would I have to do? I'd have to work out, probably use 2 equations. I might have to work out U first, which is fine, because they're asking for U anyway, but they did ask me to work out V first. So I'm going to use S equals VT minus a half AT squared. So S equals VT minus a half AT squared. Let me put my numbers in. S is 238. V is what I'm looking for. Multiplied by T, which is 14. So that's V by 14 or 14V. Minus a half. A is 2 by T squared is 14 squared. Right, so do this calculation. Use your calculator if needs be. 238 equals 14V. A half of 2 is 1. 14 squared is 196, so it's minus 196. So jump the minus 196 across and add it to that, and I will get 434 is equal to 14V, and then V is equal to 434 divided by 14. So get your calculator out for that. So 434 divided by 14 gives me an answer of 31. And look, when you're finished, make sure you write down the units. I mean, it's meaningless without any units. The units are meters per second. So there's my final velocity. They're also saying, what is the initial velocity? They're asking me, what is U? Look, you now have 4 bits of information. So when I have 4 bits of information, I can use whatever equation I want. The easiest equation to use, I would say, is equation number 1. V is equal to U plus AT. So V is 31. U is what I'm looking for. A is 2 times 14 for T. So 31 is equal to U plus 28. U is equal to 31 minus 28, which is equal to 3 meters per second. So my initial velocity is 3 meters per second. I'm accelerating at 2 meters per second every second for 14 seconds to bring me to a final speed of 31 meters per second. And that time I travelled 238 meters. Let's go on to example 4 in your notes. So in example 4 is telling me that the initial velocity of a body is 20 meters per second. It is decelerating at 4 meters per second squared. Find, and in bold, they put the distance. So we're going to make a very important point in this particular problem. Travel by the body in 8 seconds. So let me look at this very important question in great detail. So there's my question. Again, draw a simple diagram, which is just a straight line. You can always turn the maths and the words into a simple diagram where everything's in front of you, and then it's much easier to proceed and solve the problem. So here's my simple diagram, straight line. So what do I know? I know the initial velocity, we call that u, is 20 meters per second. So it starts here with a speed of 20 meters per second. It is decelerating. So when we talk about deceleration, we're going to put a negative on the A. So if I'm saying it's decelerating at 4 meters per second squared, I'm going to put my arrow for acceleration. Slowing down. I'm going to write down A is minus 4 meters per second squared. The minus 4 means that every second its speed goes down by 4 meters per second. So if it starts at 20, after 1 second it's going to go to 16, and then to 12, and eventually it's going to stop. And when it stops, it's then going to go and have a negative velocity. It's going to start moving back in the opposite direction. So once it's got a positive velocity, it's going to move to the right, and then it's going to start moving to the left. Now this is tricky. They're asking me for the distance, but S is, in my formulae, S stands for displacement. Now remember what displacement is. Displacement is my distance from my starting position. So I said it in the previous class. If I stand here and I walk, say, 1, 2, 3 meters, I've walked a distance of 3 meters. My displacement is also 3 meters because I'm 3 meters from my starting position back there. But if I turn around and I walk back 1, 2, 3, now my total distance is 6 meters, 3 and 3. But my displacement from my starting position, my distance from my starting position is 0. And in the equations, S stands for displacement. So I need to be a little bit careful. So keep that in mind. We're talking about find the distance traveled in 8 seconds. So we're talking about a time t of 8 seconds. Well, the good thing is you've got 3 letters. And if you've got 3 letters, then you can work out the other 2. Well, I want to work out S, which stands for displacement. Now, this is an important point. Displacement and distance are the same thing if you don't change direction. So as I said, if I started here and I walked 1, 2, 3 meters and stopped, my distance is 3 meters, but my displacement is also 3 meters because I didn't change direction. It's only when I turn around and go back, say 1 meter, now my distance is 4 meters traveled, but my displacement is 2 meters from where I started. So that's the idea. So let me work out S. What equation will I use? What am I missing there? Well, I've got no V. So what does no V mean? If I look at my list of equations, no V means equation number 3. S equals ut plus a half at squared. So let me write down that equation. S equals ut plus a half at squared. So plug my numbers in. So S is equal to U 20 times T 8 plus a half A minus 4. T squared is 8 squared. So S is equal to 160. That's minus 2. 8 squared is 64. I get minus 128. So I get a displacement of 32 meters. So that is my distance if I didn't change direction. How do I know if I changed direction? Well, to change direction I have to stop. So what I would like to do is this. I would like to know how long it takes me to stop. If the time it takes me to stop is over 8 seconds, then that's my answer. If it's less than 8 seconds, then I've got to think about it. So I'm going to write down here, V is equal to 0. That's stopping. And the question is, how long does it take me to stop? So what information do I have? I have u is equal to 20 meters per second. I have v is equal to 0 meters per second. And I have my acceleration a is minus 4 meters per second squared. And the question I want is, how long does it take to stop? So what equation will I use? What have I got there? No s. What equation is no s? It's equation number 1. Equation number 1 is v is equal to u plus at. So 0 for v is equal to u20 minus 4 for a times t. Solve that for t. 4t is equal to 20. And you've got t is equal to 5 seconds. So actually, it takes 5 seconds to stop. So let's say it took 5 seconds to come across here, then it stopped, and then it started going back this way, and at the end of 8 seconds, what was its displacement from a starting position? The answer is 32 meters. So after 8 seconds, let's say it's here, and that distance from its starting position, that distance there is 32 meters. It's not my answer, of course, because what did I do? I started here, I travelled across, I stopped, and then I went back, and that's where I finished after 8 seconds. 32 meters from my starting position. So my displacement is 32 meters. Well, what's the distance? Well, I need to know this bit here, that I travelled and then went back. Well, why don't I find the displacement after 5 seconds? The displacement and the distance after 5 seconds are the same thing, because I'm keeping going in the same direction. So why don't I find the distance travelled after 5 seconds? So I'm going to write down s is equal to ut plus a half at squared. S is equal to u20 by time, 5 seconds, plus a half a. I'll speed this up a little bit. That's minus 2 by t squared. T squared is 5 squared, which is 25. That's equal to 100 minus 50. That's equal to 50 meters. So I travelled 50 meters after 5 seconds. This total distance after 5 seconds from start to when I stopped, that distance there, that's 50 meters. Now you can work out this distance here. That distance there will be 18 meters. So now what's the total distance I travelled after 8 seconds? It took me 5 seconds to go from here to stopping. That's 50 meters. And then I went back that way. That's 18 meters. 50 plus 18, well, that's 68 meters. So my answer for the total distance travelled is 68 meters. So that was a really nice example to show you that distinction between displacement, which stands for s in my formulae, and distance. So you need to be careful. You're actually talking about vectors, which we'll be doing in the next section. Okay, so that's me finished doing lesson 1, horizontal UAM. We did some very nice questions there. You've already done from exercise 1. You've done question 1 from A to T. That was just practicing those 5 formulae. So you become very, very slick using them. Now, we're kind of moving now into more wordy questions. So you've got from 2 down to 11. Last couple are challenging. You got to do a little bit of thinking for them. Look, the most important thing when you do applied maths is to do problems. That's what it's about. I love applied maths because I don't have to learn definitions as such. So it's just about problems, problems, problems. That's what you've got to do all the time. So it's up to you guys to do the work now. If you don't put the work in, if you just go from class to class watching me doing problems, you're never going to get any good. It's a self-learning subject. So all I basically do is I come in here and I just show you some techniques. I do lots of different kinds of problems. I talk about my ideas, but then it's over to you. If you're going to get a H1, you know what you have to do. You have to do it yourself. So, having finished lesson number 1 now, be able to derive those equations using simple algebra, and then just be able to do lots and lots of problems. And now, the next part of it, we'll be moving on to lesson number 2.